So let me go over your latest assignment. And right now I've just added another drop assignment, and I might up the number of dropped assignments to 3, right? Currently we had 1 drop assignment because that's the way the bonus problem was going to work. So I've upped it to 2 dropped assignments, right? So for right now, except for the quiz that we'll have closer to the end of class, we will, or closer to the end of class, we will go over I want to go over this last assignment. So,
I still doing the game of life one.
there's going to be nothing new. You've got today, so you've got Tuesday, and then you got Thursday, and then basically you don't have to demo this one. You got to show me a working copy basically before I leave the country, or before final grades are due, which I think is around the same time. So now this one, and as I said,
what do I need to do? I just need to know what I need to do.
Well, let me again talk about this. I also said I upped the number of dropped assignments. So while I've added a new assignment, I've also increased the number of assignments that you can skip by 1. So so let me go ahead, because I want to give people the chance to work on this. All right, so this one's called Fox and Rabbit, and it just went up. I will point out that one of our students did get it early, but only because I asked him if he was willing to do some debugging, right? So and make sure it was working, because there were problems reported for on Mac systems, and you didn't encounter any. Awesome. So it should work for everything. So let me go ahead and show it to you. So the idea here is assignments. Okay, is we are going to play a small game. Okay, so I'm giving you essentially a fully working program. Okay, it's located as a zip file. Okay, I'm giving you a fully working program. Okay, and if you run it's called Rabbit Hunt. And if you run the program, you're gonna get something that looks like this. Okay, give me 1 second. You will get this. Okay, let the hunt begin, and so it will look like this. So it generates a random board, and what this does is that you've got a this red dot, which represents the fox, and this brown dot that represents the rabbit.
It's yellow.
Is it yellow? Looks brown on my computer. So, and then you've got bushes, right? And what this game does is that it simulates essentially a fox that is hunting a rabbit. Okay? And when the fox finds the rabbit, it eats it, right? Okay, so this is a very simple game. You've got a rabbit that hunts you've got a fox that hunts a rabbit, right? And we can create a different board. It starts off in randomly, and the fox basically has a strategy and it's going to hunt the rabbit. Okay, so this is the game. Okay, so here, and the rabbit's going, and the fox hunts it. And after 22 turns, the fox has eaten. So if the fox eats the rabbit, it got dinner, so it's obviously won the game, right? If the rabbit escapes for 22 turns, sorry, not 22 turns, for 100 turns, you can do 22, I'm sure. 100 turns, it wins, okay? So the rabbit wins the game if it escapes for 100 turns, okay? You are playing as the rabbit, or rather, you're going to be coding up the strategy for the rabbit. Now, the rabbit does currently have a strategy, and it is terrible, as you may have noticed. It is essentially move at random. So how do you get a grade for this assignment? Excellent question. So we also have a grader. So I did not come up with this assignment, by the way. Somebody else did a number of years back. So we have this grader that we can run, and your grade on this assignment is equal to the percentage of times the rabbit wins. So this time the rabbit escaped 1 time out of 300, so this person got a 0 because the strategy of moving at random does not really work. So you were given a whole lot of code, though. It's a working program, okay? So let's take a look at what all you have. So let me go ahead and delete the irrelevant. So let me go ahead and just actually open up the relevant stuff. Okay. Open. So we've got animal, bush, controller, fox, grader, model, Java, rabbit hunt, and view. So these are all the files you've been given. Now that seems like a lot, but the only thing you have to modify, the only thing you are going to modify is the rabbit class, which is what. And the only thing you're going to modify is one method, decide move, in the rabbit class. All it currently does is it returns a random model.min direction, model.max direction, and I'll go over what those mean in a bit. Okay. First off, let me go ahead and just describe what these things are. So first ones we're going to look at are model, controller, and view. Two of these you can completely ignore, and I'll describe why. The first thing is that this is a graphics program. You can see that there were graphics on the screen, okay? Now, the way graphical programs typically are broken down is that they are broken out into what's called a model, a view, and controller interface. So the view represents what you physically see on the screen, right? What gets displayed to us. So if I run Rabbit Hunt, right, it will display the view to us, right? I can interact with the view by using the controller, right? And the laser beams are basically calling a method to help it to visualize how it works. So the controller is all these, like how I handle all these button presses and me saying I want to hit the next thing, right? So if we look, like it says, the controller create GUI, set delays, how to deal with handling the windows, what happens when you press a certain button, right? Those kind of things. So you don't have to worry about the view or the controller. Those simply talk about the graphics, right? So what's important is the model, which basically is the actual simulation itself. It holds the rules for the game. It talks about how everything relates to each other, okay? The Rabbit Hunt class is, as you can see, it creates a model, view, and controller and runs the program. So that's why I run the Rabbit Hunt class. The model basically it's the model of the board. So let's take a look at what it is. It's a 2x2 array of objects called a field, right? It takes place on a field. That makes sense. It has a number of rows. It has a number of columns. There's a rabbit. There's a fox, represented by the private variables rabbit and fox. So the reason they're private is because that, again, the only code you're allowed to modify is the rabbit class, okay? So you can't modify the rabbit or the fox here, and so they're private, so you can't have access to them. So all these things. There's also the rabbit is alive, game is over, steps taken, maximum number of steps. So then here are the useful things, the statics, like static int, number of rows. How many rows are there? Static int, number of columns. A static vector looks, whose turn it is. Then static final int n, ne, east, southeast, south, southwest, west, northwest, and stay. So these are all variables that represent a direction. So to make comparing what direction is what easy, we store them as integers, but to make sure we don't actually mess them up, we can basically encode, north as 0, northeast as 1, east as 2, southeast is 3. So I can call them in the rabbit class by basically saying int. I can basically go model dot n and have basically the north direction because it's a static variable, right? Since it's static, I don't need a model object. Although it does look like I do have access to a model, right? We'll have to look at the animal class. Oh, the model's private there. So, okay. So then there's a constructor, Then there's allow single moves. So you'll want to look at what statics are available to you, right? Static row change determines how moving in a given direction will affect what your row number is, right? Column change determines what, like, if I move, what will my new column be, right? So these are useful things. Checking if it's a legal location, you can checking if a location is legal. Look determines what can be seen from a certain location. Anyway, so those are things that basically you have access to. Model has some useful variables for you to look at. Now, what's important, though, is that basically we're modeling also the actors on the screen. And you have the bush, which is, they don't do anything, they're just there, right? It's a very simple class to represent the bush. So let's go ahead and look at basically the main stars of these. So we have Fox, which is this whole thing, and we'll go into Fox because if you have no idea where to start, I suggest start by looking at your enemy, right? Because the enemy's code, the way he's going to figure out how to get you, is all laid out right here for you to reverse engineer. Okay? So the rabbit, first off, public class rabbit extends animal. That means the rabbit is an animal, right? That means that all the things that an animal can do, the rabbit can do, right? And then the other thing is that it decides a move. What it returns is an integer. What does the integer represent? It represents a number between the model min direction and the model max direction. So what is model.min direction? Okay, min direction is 0, max direction is 7. In other words, it's representing the numbers 0 through 7, north through northwest clockwise. Right, it's just choosing a random direction. So what you have to return is a number 0, not through 7, but through 8 to represent what move the rabbit's going to move next. 8, by the way, represents staying right here. So what can animals do? Let's take a look. So animals, they have a row and a column, right? They have a place where they exist. And then they have a couple of methods that they can use to help them do what they need to do. You can have your animal look. So I can have my rabbit look by going this.look. And what that does is that it finds the first visible thing in a given direction, starting from this animal's current position. So it's going to return an integer. Now, why does it return an integer? Because in the model class, it says that a 0 will represent the edge of the playing field, right, the border, right? 1 will represent a fox, 2 will represent a rabbit, and 3 represents a bush. So for instance, if in my code I'd go so int thing is equal to this dot look 0. What I'm doing here is I'm telling my rabbit to look north. Okay? Makes sense to everybody? I'm looking 0. I shouldn't probably tell it to do that. If I wanted to look north, I should probably tell it model.north though. Look more model.north. Right? And I'll get a thing back. And then I can ask myself, hey, is that if thing equals let's go with model.fox, I know that the fox is to the north of me. I can see it, right? Make sense? Right? So I can use that to get information. It will return a thing. And then I can know what that thing is by comparing it to the model numbers. Okay? What else can it do? Well, similar to look, once I see a thing, I might be interested in how far away it is from me. So I can use distance to figure out how far away something is from me. This one's also useful, asking if I can move in a specific direction. And then, right, we have the decide. Every animal has a decide move, which had defaulted to just staying put. Right? So we are obviously overriding that. So let's go ahead and take a look at Fox to see an example of what you've done. So you can add as much code as you want to your rabbit again. So, and that's what we did with Fox. So it has two booleans. have seen rabbit. Have I seen the rabbit? Yes. Do I know the rabbit exists? And Boolean, can I see the rabbit now? Right? And then I keep track of how far away I am from the rabbit, the direction to the rabbit, and the current direction I am going. Right? So that's what the fox does. And the code is commented, which means that it's there for you to read. So I'm going to help you by reading through it with you. Okay? So the int decide move. This is how the fox is chasing down your rabbit. Can see rabbit now is equal to false. So for int I in model.min direction, so from one direction to the next direction, up through, so note the less than or equal to over there, I++. If I look in that direction and I see the rabbit, right? If look I equals model.rabbit, then this is a statement we haven't seen. It's a compound assignment over here. This assigns, so this says that can see rabbit now is equal to the value of have seen rabbit, which is true, right? So this just simply sets both these variables to true. It's better practice to do that as 2 lines. So if I see the rabbit, well, obviously I have seen it and I can see it now. I set the direction equal to the direction I'm currently looking, and the distance to the rabbit equal to the distance to the object in that direction, right? Fairly straightforward, right? This is a loop already there that tells you how to find something, right? Specifically, it's if I can see the rabbit, right? So if I have seen the rabbit, then this loop moves me towards the next, its last known position, right? If I have seen the rabbit, do this, right? If I haven't seen the rabbit, or maybe I lost track of the rabbit, either I continue in the current direction, maybe by dodging bullets. So as you can see here, its strategy is fairly, robust, right? So if I can see if I have seen the rabbit, if I need to get closer to the rabbit, I do. Otherwise, if the rabbit was here, where did it go? If I have seen the rabbit, so if the rabbit was here, so if I go to where the rabbit was and I haven't ended the game, then I set have seen rabbit to false and I start wandering around. Okay? If I haven't seen the rabbit or lost track of the rabbit, then this is what I do. I look if I can move in a current direction. Else, he does model.turn. He asks if he can do this. Right, so he looks like he turns a bit and decides to move in a certain direction. So there's a there's a lot that goes on there. But for the most part, it's fairly simple. My advice to you, again, if you have no idea where to start, is try reverse engineering this code, right? So, and do that over here, right? And your objective is to stay away from the fox for 100 turns. Okay? So I might change the grading criteria depending on how well you got on how well this goes, but this is what I think will be a very fun assignment for you guys.
What if you don't find programming fun?
What?
Nothing.
So, anyway, that's what I've got for you. I'm going to go around and answer individual questions and check off assignments and the like. We will have a quiz today on object-oriented programming, which I hope will reinforce the topics. And like I said, the question from the exam, you can expect that exact question on the final since everybody missed it. So that's a pretty good indication. When everybody misses a question, it's a good time to ask it again.
So